Hello student, in this lecture I will discuss about stability analysis. So let's start our discussion. In designing a control system, the main objective of a control system engineer is that the designed system must be stable when it is subjected to command signals, extraneous inputs anywhere within a loop, and changes in parameters of the feedback loop. Stability is a very important characteristic of any system. Stability of a system implies that small changes in input do not result in large effects on the system response. We call a system stable if its output is bounded for any bounded input. So, what is a bounded input and output? The examples for bounded and unbounded input and output signal are shown in this figure. See, in figure A, we can see that the magnitude of an exponential function e to the power minus 80 decreases to 0 as time tends to infinity. See the next figure, that means the figure B. Here the magnitude of a unit step function is 1 even when time tends to infinity. Now see the figure C. The sinusoidal function a sin omega t, here the sinusoidal function a sin omega t varies between two limits plus a and minus a. This type of quantities are said to be bounded. On the other hand, the exponential function with a greater than 0 increases to infinity as time tends to infinity, as shown in figure D. So, first three are bounded input, okay. So, bounded output, first three are bounded output, okay. So, next two, that means figure D and C. So, in figure D, we can see the exponential function with a greater than 0 increases to infinity as time tends to infinity. Similarly, the amplitude of an exponentially increasing sinusoidal function increases to infinity as time tends to infinity, which have shown in figure E. Okay, so we call these two functions as unbounded function. Okay, so first three are bounded function and last two are unbounded function. Now see, a system is said to be bounded input and bounded output stable if for every bounded input the output is bounded. This criterion is known as Bibu stability criteria. Typical stable and unstable system are shown in this figure. See the first figure, that means figure 3.2a. Okay, so in this figure, so here shown in this figure, we have shown stable and unstable system. Okay, so if for a bounded input the output is unbounded, shown in figure 3.2b, then the system is said to be unstable. Okay, so when the system is unstable, if for a bounded input the output is unbounded, then the system is said to be unstable. A condition on impulse response for Bibu stability can be easily obtained using convolution integral. Okay, so what is bounded input or what is stable system? So if for a bounded input, the output is bounded, then this system is stable system. But bounded input, the output is unbounded, then the system is unstable system. Okay, so here first system is stable system because here we are getting bounded output, but the second figure is unstable system because here for bounded input we are getting unbounded output. Okay.